Hello, and welcome to part 4 on my series of understanding polymorphism in Unity. The last time we were covering strategy pattern, which combines the code reusability of simple inheritance with the flexibility of interfaces, and gets the best of both worlds to create a system that's very easily extensible and doesn't involve a lot of repetition. But despite the power of that system, there's still one thing about it that isn't quite as good as it could be. Any changes that I want to make to it have to be changes in code. So if I want to change my dog so that instead of walking, it dances by default when it needs to move, I have to go into the code class and change it. Now that doesn't seem too bad because it's not a whole lot of changes, just one word here. I could add more move states that way without too much difficulty, but it doesn't really take advantage of some of the features that Unity offers, specifically that of separating the programming aspect of a project from the design. And by design, I'm referring to arranging the game's content, setting up levels, designing characters, writing dialogue, balancing attributes, just the kinds of things that the user actually sees, as opposed to the core game mechanics. Like if you're a solo developer like myself, one person can fill both of these roles, but it's still, I feel, useful to think of them as being different roles that I switch between on different tasks that I work on. So when I'm programming a game, I don't want to be building the way the game plays as part of the programming. Instead, it's better to think of it as building the kind of tools that I will need when I go into put on my designer hat and just be able to use those tools to actually build the game and set up how it plays. So determining how the game plays based on having to make modifications to code all the time is not really ideal from that perspective. Alright, so let's get into how this works. So I'm in my new scene, which now the animals have multiple components attached. If you remember in the previous scene, it just had a single dog, or a single like an animal script attached to each game object, and these would be calling behaviors that aren't attached to any game object. Instead of that, I'm going to put everything that's going to be used into actual components. So a cat, for example, has an animal script as well as a walk and a meow. Giraffe has animal, walk, and silence. Dog has animal, walk, dog paddle, and bark. If I look at the actual code, the player code stays the same because we haven't changed how input is handled. It still finds the character component, or which in this case can be animal or robot, since these just inherit from character. Animal and robot are empty, by the way, because I want to preserve the option later of being able to make animals and robots behave differently in some fashion, which is yet to be determined. So by just inheriting from character and leaving it blank, it's essentially the same as if all of these just had a character component attached to them. Alright, so let's take a look at that character script. And the first thing you may notice that's changed is now instead of move and speak behavior just being single variables, I have them set to arrays. And I could use lists just as well. There might actually be benefits to that, but for now, arrays will work fine. So I declare my arrays, so it can be any number of move and speak behaviors. And in the start method, I will get all of the components that include the iMove interface and all of the components that include the speak interface. So imagine that like at start, animal is going to is going to run the get components command. So it'll iterate through each of these. And so say it gets to walk, this has iMove. So that's going to be added to the 0th element of the move behaviors. Then it'll go to the next element, dog paddle. This also has iMove. Dog paddle will become the first element of move behaviors array. Look at the next item. This does not have iMove, but it has iSpeak. So what will happen is this is finished. It only has 2 elements, 0 and 1. And speak behaviors, it'll have passed over all of these other components until it gets to bark, and that'll add that to the 0th element of the speak behaviors array. Now the reason I'm using arrays here, and I probably could have done this the previous one, although I would have had to do something other than get components. I'm not exactly sure what. But because they're arrays, when the player presses the space button and calls this change move state, which is here, this is essentially just a cycling through elements in the array. So when I am at the end of the array, I go back to position 0 and otherwise increment up by 1 position. And this move ID and speak ID is what I'm going to be using to pick out specific elements of these arrays when I'm using them. So let's go through an example. So I run the game here, and I'll just be using right clicks. I right click on the dog, and it says dog is walking. Well, why is that? Because went to perform move and calls this line right here. Move ID initializes at 0, and I haven't changed it, so it's still 0. And the 0th element of move behaviors is walk, because walk is above dog paddle. Speaking of which, if I were to rearrange these components and put dog paddle above walk, then dogs would swim by default. But I didn't, so walking is first. So it calls the walk component, this right here, and calls the move method within that, and it passes itself as a game object. Then move takes in its character name, which was passed in as an argument, and runs and then does whatever it does. In this case, it's just a single line saying character name is walking. Now, go back in this game here, I press spacebar over the dog, and what will have happened is call change move state. I'm not at the end of the list, so now move ID goes from 0 to 1. Back in the game, I right click, dog is dog paddling, because this called perform move, and move ID is now 1, so it accesses this component, dog paddle, which again takes in the character name and displays this line. And again, for now, this game is very simple. I'm just trying to illustrate the concept, so it's just a single debug log line. Realistically, I'd have a lot more here. This would be everything that's involved in dog paddling. I can even add new behaviors here. So let's say I want it to be able to walk, fly, or swim. I can just throw in a swim component here and see. So it's flying, walking. Oh, maybe. Oh, wait. I'm not able to do this at runtime because the arrays are already filled. So take in a swim component there. Robot is walking, is flying, is swimming. Walking, flying, swimming. So now it's able to cycle between all three of these. And I'm able to add that kind of functionality without changing the code at all. So the amount of work and flexibility hasn't really changed significantly since using the regular strategy pattern. Actually, I'm going to go ahead and remove these components. There has been some reduction in the amount of code because I no longer really have need for a lot of different characters since they're all implementing the same methods currently, so I'm able to include everything up in the character class and not really need inheritance along this line any longer. However, if I wanted certain features to be different between giraffes and robots and dogs and so on, I could easily create new classes that inherit from animal or from robot. If I wanted robots to be different from animals, I could add functionality here. The main takeaway of this change is that it's now all being done in the inspector, which means the gameplay can be customized by a designer who doesn't necessarily know anything much about programming. If new functionality needs to be added, say we want to add like a dancing method, that would require creating a new movement behavior. So like this is swim, then I could say go about that by creating a new C# script, call it dance 7. And it'll be just like the other ones. I'll start that. It'll still use the move method name is dancing. Okay, and now I can attach that dance action to whatever I want. So let's say I'll give the cat the ability to dance. Now it can dance or walk. And right now I've made dance its default option. I think I'll make it a secondary one. So now I can click on this cat and press the space bar. Oh. And now it's dancing. Space bar again, and it's back to walking. So genuinely new functionality requires a little bit of coding. If I was to add complexity to what happens on the dance, then I would need to actually add more code here. But once the elements and the tools are in place, then everything's in the hands of the designer to be able to actually build the game. And this kind of setup here is really how Unity is meant to be used. So I think I'm going to put this project up on my GitHub and have a link to it in the description below. Have a whole bunch of different scenes building up in complexity. This is really the pattern that I would recommend using. I mean, you could use it for an inventory system, for a character building system, almost anything you would want to build in a Unity game. you could use this kind of pattern of separating out the behaviors from the characters. You might need more different things to delegate out. So rather than maybe moving and speaking, you might also want to make an array of attack behaviors, or any number of other possibilities. Although I'll also include these other 6 scenes as a reference, because in a way this sort of uses the concepts from everything before it. It takes the strategy pattern and brings it into the Unity paradigm, and strategy pattern is based on both inheritance and interfaces, which are covered here. So hopefully you find that helpful. If you like, I can show this in action in an actual game that I am working on. But otherwise, if you have any questions or comments, feel free to leave comments below. And until next time, this is Will Patillo signing out.